So we are going to draw a space curve by using Matlab. So first let's consider this example, which is example of a circular helix. Okay, so we are going to graph cosine t sine tt as the xyz coordinates, functions of a single parameter. So right now let's work in just in the command window. Later on we will work in live script. Okay, so I just defined a symbolic variable t, and then I want to do what? Just make a graph of this function. Okay, so I'm just typing it in. All right, and remember this, we wanted our range for t to be from 10 to 10, and I'm just going to introduce one feature here which is pretty handy to write right here instead of working in the graphing window later. So for me, line width of 3, that is the thickness of the curve, that works. So we'll see, we can change it the way you want. So here we should have a graph, okay, and it should show up in another window where, yeah, here it does. Okay, so this is the graph of the graph of a circular helix, and we can do this. We can say x is equal if we would like. All right, so that will change the graph to this format. I like the earlier one better, but anyways, okay. Now if you do this, you can just go through these menu items and play with this at your own time. One of my favorites is to be able to rotate it, and this is a projection in the XY plane. Okay, and say we want to see, for instance, another property. So you may notice here that the helix, or this right circular helix that lies on this cylinder, okay, x square plus y square equals 1. So now, so let us draw the helix. Let us draw the cylinder to show that helix lies on the cylinder. So we are just going to ask it to hold on to the other graph. And now that we are going to go and define a symbolic variable in x, y, and z, and of course here we have a cylinder, so z would not take any other value. So say we got x, y, z, we will just define it as x square plus y square minus 1. So f is defined here, and now we are going to draw an implicit plot, right? Because we are not going to give z as a function of x and y. So the way we can write that command is this, that we want f implicit in 3 dimensions, and then we have we put in the command line, we put 2 equal signs. Yeah, I'll tell you a reason later. Okay, so and then we can just keep the window a little wider than the required window. Okay, so this is what I am writing for the range of values of x and y, and that is for z. Okay, and there we are. Okay, so hopefully it should graph the cylinder right above the helix for us, and it did, right? Okay, so let's rotate and see. Now you can change the thickness and the color, etc., instead of typing it in the command by just selecting figure properties and right click. So line style, line width, I remember I chose it as 3. You can change it to thicker or narrower, whichever way you want. Okay, and also I'm right clicking here. You can change the color if you would like. Okay, so for instance we want to take say this red color here. This will change to red, and say you want to redraw the cylinder on that, it will be, you know, a little more visible here to you. Okay, that is like this here. Okay, let's go back to graph, and you can see you can see the difference between the two much better now. All right.